Here with my very poorly drawn person, we are looking at the dangers of electricity. So we're all probably aware that if you touch something with a certain amount of, let's just say we've got this thing here, which is, 50 volts. Well, there's a potential difference between that because between your hand and, between this and the ground, there is a total potential of about 50 volts because this should be at 0, okay? And things want to go from high to low, so we get it goes through here. Now, normally, so 50 volts isn't very high, all right? So, I've done more than 200 volts on AC and hadn't really noticed much apart from I did feel it. But the thing is that your body has got a certain amount of resistance, so, not much is really going to happen with this. A lot of it will just go straight over your skin. But the other thing is your body also has a ready-made pathway for electricity to follow quite easily. It's full of ions, it's full of liquid, and it's a very well-connected network, and that is your circulatory system. So what could happen is that, the circulatory system centers upon the heart. So what could happen if you had a sufficiently high voltage, so let's call that 50 kilovolts, what could happen is it would go through your heart to the ground. Usually, actually, it skips your brain, okay, because it's not a very easy path. It doesn't randomly just take longer paths. It wants to take the shortest path possible to get down to that 0 volt potential. And so what it will do is it will go through the heart. And obviously, that's really bad. Your heart can't really stand very huge currents. So, yeah, it could badly injure or kill you. Or even, at the very least, throw your heart out of rhythm, which is obviously not exactly what we want. So we want to think about the hazards which would expose somebody to this. So we could, for example, imagine a wire, but a wire which has been damaged. So we've got the wire core is kind of exposed. So you might see this in some places. You would see the little bits are all frayed, and so this could obviously be a bit of a danger because the insulation protects you. With no insulation, that means the current can get to your hand or whichever part of your body is touching it. Okay. So obviously, if you wanted to manage that risk, you would probably wear safety gloves if you had to handle wires like this. There's lots of other ways of doing that. Okay. One other thing as well that could happen is even if you weren't touching it, if somebody spilt some water. So there's water in the environment. Usually water contains some minerals which conduct electricity. So the electricity will go in through that water, and anything touching that will experience an electric shock from it, or could experience an electric shock from it. Another thing as well is, of course, if you had a very high current in a cable, it could overheat. It could cause a fire. So let's think about what that actually does. So we have a cable and it overheats because the current is too high. Well, this is the case when we would use a fuse. So that's the symbol of a fuse. Essentially, it is a little cylinder that contains a very thin wire. And that wire has actually got a specific thickness. So it looks like this. It's got a specific thickness for a particular current. So if the current gets too high in this, it just melts. If that melts, suddenly the circuit is broken and nothing more flows. The fuse is ruined, you need to buy a new one, but it does protect the circuit and it protects anybody from being hurt by that. So fuses have their ratings. So this might, for example, be a 2 amp fuse. That means it will burn out at 2 amps. So, if you had, let's imagine a lamp, okay, and it had its maximum, the maximum safe value of this was 1.5 amps. Okay, you need to protect that. So a 2 amp fuse is too strong. Okay, you'd ideally want a 1.5 amp fuse, but that may not always be available. So one question you'll often see is where you have to choose different values for a fuse. Of course, if you're given the options of 2 amp, 12 amp, 3 amp, and 9 amp, then, this is the least worst option to choose. Okay, but if it goes beyond 1.5 amps, there's probably the chance it'll just burn out. Probably won't kill anybody, but the bulb would burn out and just be ruined. It wouldn't be very well designed. That's kind of it for dangers of electricity. Oh, no, I want to talk about something else. So let's talk about this in terms of a circuit diagram. I'm going to talk about this idea of a short circuit. So here we have our power supply or battery, whatever it is, and we've got 12 volts again. And we've got some component in this circuit. So let's just say it's a washing machine. So we've got a motor, and we've got, there's got to be a heater as well to heat the water. We'll just say there's little lights for the screen and this kind of thing. Drastically oversimplified. Now, that's your circuit working just fine. Okay. And we've got some potential difference across all three of those. So it's going to be 12 volts again. Well, it should be actually 240 volts, but there it is. So we've got 12 volts. Now, what could happen is, let's say, for example, it had gone wrong, it was broken, or it was damaged. We could, for example, have a short circuit. Now, this would represent some water maybe getting into the electricals of it. And so what would happen is that water would make a shorter path, so it avoids the resistance of those. Now, if the resistance is lower, that means the current is much higher. So we get this very high current here. And that high current could, at the very least, just really badly damage the washing machine. Or if it made contact with the metal outsides, it could mean that anybody touching it would be exposed to that electrical danger as well. And it would be 240 volts, just to show that it's actually scarier than that. And so if we bypass the resistance, the current gets very high, so that's dangerous. So what we have is, in various places, fuses will be fitted. So there'll be a fuse, and maybe that's rated as a 3 amp fuse, so that if we get this short circuit, which passes this resistance, it's much, much lower resistance than this, so nearly all the current goes through there, then that means the current gets very high. But as soon as the current gets to 3 amps, the fuse burns out and switches the circuit off automatically, protecting the machine itself so it can then be fixed, and protecting the people so that they don't die.